This is the Building Automation Monthly Podcast with Phil Zito, episode 108. Hey folks, Phil Zito here, and welcome to episode 108 of the Building Automation Monthly Podcast. And in this episode, we will be finishing up this series on systems integration. So if you haven't heard the prior two episodes, I would encourage you to check out episodes 106 and episodes 107 prior to listening to this episode, because you are going to be missing a lot of the fundamental and foundational knowledge that you need to really take in what is in this episode. That being said, in today's episode, we're going to be kind of putting a bow on this topic of systems integration. We're going to be wrapping it up, and we are going to be kind of finalizing what we've learned so far by looking at 3 different integrations from start to finish. So we're going to look at a physical integration, a protocol integration, and we're going to look at a programmatic integration. We're going to go through each one. We're going to start at the business outcomes and work all our way down to the actual implementation of the integrations. I don't know how long this episode's going to go. This might end up actually being a fairly long episode, depending on how deep we go into each individual integration. Now, as you may or may not remember, there are kind of a couple questions that you need to be able to answer prior to going and doing any integration. And those are, why are you doing the integration? What outcomes are you looking for with the integration? What are the user's preferences? Who's going to support the integration? And what systems does the integration have? So these are the kind of questions that we're going to want to be able to answer prior to even starting our integration. And then once we've done that, once we've actually answered those questions, then we can go about the process of actually implementing the integration. So up to this point, I've talked around the details of implementing integrations, but in this episode, we are going to dive pretty deep into that. Whenever you're looking at implementing an integration, there's really kind of 4 areas you want to look at. And so as we move through the integrations that are in this episode, and as we answer our 5 questions, we then are going to move to our 4 areas that we really have to go and be really clear on if we're going to be able to implement the integration. The first is the physical connection. And oftentimes this is misunderstood or just not properly appreciated for its complexity. When you're dealing with a quite simple integration like a physical integration, which is one of the integrations we'll deal with first, the physical connection is not that big of a deal. I mean, it's usually a 2 or 3 wire connection. But when you start to get into programmatic and protocol integrations, you have multiple different physical points that could make or break the integration. Next is the data connection. And this becomes a issue when you're dealing with protocol and programmatic integrations. This is where you have things like data models. This is things where you have data adapt-in patterns, where you have to go and basically take one form of data and convert it to another. And we'll be talking about those. Then you have the programming that's involved to actually make the integration work. This is across all 3 kinds of the integrations. And then finally, you have a way of interfacing with the integration, both from a support perspective as well as from a user perspective. So a lot of different things that we've got to unpack. The 3 integrations we're going to go through, we're going to look at a physical integration of tying a pulse meter into a building automation system. Then we're going to go and look at a protocol integration of taking a backnet lighting system and taking it into a backnet BAS system. And finally, we're going to look at a API programmatic integration of pulling data from a weather station into a building automation system. So 3 kind of relatively simple integrations, but they're going to cover all of the things we've learned so far throughout the past episodes and kind of really button all this up. So let's dive into the first integration. Pulse meter to BAS. So we go through asking our questions. Why are you doing the integration? Well, quite simply, want to be able to pull in that utility data into the BAS. Okay, that's good to know, but what outcome are you looking for from having that data? Well, maybe you've got an energy manager, and that energy manager wants to calculate the utility load from the HVAC equipment, as well as the metering and electrical and gas and water, and they want to get a full picture of what their entire utility profile looks like. So that would be the outcome, would be to go and have a picture of their utility. Or would it? Would that be the outcome? See, that's where a lot of folks would stop. In reality, that's why they're doing the integration. The integration is so that they can get the full picture of what's going on. But the what outcome is usually something deeper than that. It may be that they've got a utility spend goal that they're trying to reduce. It may be that they're coming up on renegotiating their purchasing rates for their utilities. Maybe they buy based on a 3 or 5 year purchasing agreement for utility spends. And so in that case, understanding that is going to kind of make how you put these integrations together differently. It's going to affect them differently rather. And what I mean by that is if it's quite simply that you're trying to go and reduce utility spend for a targeted goal, well, then that is going to have all sorts of ties to potentially load shedding. That's going to have ties to potentially going and implementing different energy saving strategies with your equipment, which you may need to have the data in a different form than if you're simply trying to just go and totalize it all up. That way you know what you're spending. You may have to have a deeper level of granularity. So that's a very important thing to know. Then what are our user preferences? Well, we've got to understand who's using this. Is it the utility or the energy manager? Is this being totalized up by a facility manager? What is the user type and what are they trying to do with this? Because if it's an energy manager, they may have a level of granularity that a facility manager doesn't want to have. So at this point, we haven't talked about how we're going to do the integration, but these are all important points because the level of granularity is going to affect how often you collect the data. It's going to affect also kind of how the data is presented. Is it presented into one totalized value that gets reported out, or is it broken into very detailed levels of granularity almost to the meter level? Then who's going to support this integration? And what systems do you have? So who's going to support it is not going to be as important with physical integrations, but once we get to protocol and programmatic, that's going to be important. And what systems do you have? This is where you want to get the model number of the pulse meter that you're trying to pull in. You want to understand a couple things. What value are you measuring each time the meter pulses? Is it on a on pulse or an off pulse that a value happens? Does it pulse on and off and then that's a value? Or is it every time it pulses that you get a value? And how much do you increment that value by? Is it, 500 kilowatt hours per pulse? What is the determining value that is coming from each individual pulse? And so these are things that are going to be important for you to document and work with the different manufacturers to figure out. But now we go to actually implementing. So let's say you go and you find out that this is a 2-wire connection from the meter back to the building automation system, and it pulses through those 2 wires. Well, then quite simply, you just need to know what terminals, because this is your physical connection, what terminals am I connecting to? What is the polarity? Is this DC pulse, which it most likely is, or is somehow this AC, which I've yet to see AC pulse, but that I guess maybe. I've yet to see it though. And then you would say, okay, I've got that pulse. I know what wires are connected. I'm going to connect them to my building automation system. Identify the data connection. There's no real data connection. Now you just have to go and add a point to that field controller. You have to make sure that that point's properly configured, and then you simply map that point back into the supervisory device. Once it's in the supervisory device, you make any programming needed. Maybe you have a sum block in your supervisory device where you sum up all of the different meters and you output that to a totalization point. Maybe you're going and you're summing the values of the meters and then you're resetting it once a month. Maybe that's what you're doing. You've got to understand kind of what are you doing with the data in order to program the points properly. And finally, figure out what is going to be the way of interacting with this data. That's why you asked what the user preferences are, how they're going to be using it, what outcome they're looking for, because that's going to determine, do you put it on a graphic? Is this just a simple data point that a report runs against? I mean, how are you grabbing this data? And then kind of a bonus thing is, how do you alert when the data is bad? Do you put an alarm on the point, and if it goes unreliable for a certain amount of time, it emails someone? How are you reporting that data is actually not accurate with these integrations? That's a very, very important thing for you to address. So not too bad, right? I mean, physical integration's pretty easy to do. Most of you should feel fairly comfortable that if you can get a model number from the manufacturer of what you're trying to tie into, that as long as the auxiliary outputs or inputs exist, you'll be able to integrate, whether that's for just monitoring or for control. But now we move on to the next integration where a lot of folks get hung up at, because I'll be honest, integration number 3, where you start to use programming to pull in weather APIs and things like that, normally if you're doing that, you're at a certain level of experience and expertise that you don't run into as many issues. It's this kind of protocol integration, this middle-of-the-road integration that tends to hurt a lot of folks because they just really don't think it through, or they misunderstand what the outcome is supposed to be, especially with lighting. So why are we doing the lighting to BAS integration? So we've got these two BACnet IP systems, a BACnet IP lighting system and a BACnet IP BAS system. Why are we integrating the two together? Maybe the integration is that we want to have control of the lights. Maybe it's that we want the lights to come on when the building's occupied. Okay, so that's our why. What outcome are we looking for? In the case of, I'm going to pick the more complex of the two, we want to have control of the lights down to the individual space. So I won't say fixture, but space. So what outcome are we looking for? We're looking for a tenant experience. We're looking for a client experience. So we want folks to be able to pick up their phones and have the experience of actually going and picking their space and changing their lights. So then what are the user preferences? Well, they want to do it mainly on mobile. So you know right off the bat, if this is something that you want to do via mobile, then you're going to have to say, how do I go about addressing all of these users that are going to want to log in? Because traditionally building automation systems do not lend themselves to having dozens upon dozens of users. Normally, what will have to happen is you'll go to your manufacturer and get some form of portal software that they'll have dedicated, like for client portals and things like that. And it's actually an add-on software suite in some cases. So what are the user preferences? Well, if they want to access it via their phone, how do you want that to actually work and look? Sometimes this will actually be custom development for the front end portion of it. And you'll actually have to work with a programmer to write a custom kind of front end for this. So it really just depends on the preferences. Who's going to support it, especially if you're doing one of those custom front ends, who's going to support this? In this case, you're going to have either the owner has technical staff who can support this, but in most cases, what's going to happen is you're going to support it for a year and then it's going to get forgotten. That's just the reality. That's how construction world works. So you're going to want to think through, how do I go about supporting this past that first year? And normally this is going to look like some form of maintenance agreement for this integration. Then finally, what systems do you have? This is where you need to understand, what lighting system do you have? What model is it? Who's the lighting vendor who's installing it? What is their protocol interfaces that they support? How do you know that that protocol interface has been included? So for example, with the quantum lighting system with Lutron, you want to make sure that they have the BACnet license card to get installed that will actually go and act as a BACnet server that you can then discover and pull into your building automation system. Which now brings us up to the physical connection. So there's a lot of variables in play here. When we're talking about physical connection, there's, for one, you got to make sure that the lighting system and the BAS system are connected to the network. Then dealing with the data link side of the network, layer 2, which if you all don't know what layer 2 is and data link and all that, I really encourage you to check out my IT course. It will really help you understand that. But you've got this data link, that's the local subnet. And that is, if both your lighting and your BAS are on there, that makes it look completely different than if your lighting system's on a separate subnet from your BAS. So I'm going to pick the more challenging of the two. Let's say that the lighting system is on one subnet and the BAS is on another subnet. They're both speaking BACnet IP. Well, what does that mean? Well, that means now that you have to have a BBMD, you have to have the routes, you have to have your BDT tables entered, you have to have a way for the different subnets to communicate with one another, you have to make sure that the same ports are being used, you got to make sure that you get the right network IDs. You have all of these BACnet specific functionalities that have to be implemented properly in order for this physical connection to even work. Make sure things aren't firewalled off, things like that. From here, you go into the data connection. Now, this is where things get real interesting. BACnet as a protocol has a priority array, with the lowest number being the highest priority and the highest number up to 16 being the lowest priority. And what you have to decide, going back once again to user preferences, how will the system work, you have to decide, is the lighting panel on the wall going to be in charge? Is the lighting system going to be in charge? Is the BAS kind of mobile interface going to be in charge? What is going to be in charge? Because based on that, you then have to configure your points to write at the appropriate priority array in order to go and have appropriate control. So for example, let's say you want the mobile device to be in charge, the mobile BAS device, and it's writing at priority array of, let's just say 14. But for whatever reason, the lighting manufacturer is writing at priority array of 8. Well, what that means is no matter what you do with that BAS system, if that lighting system decides to write something, it is going to overwrite what your BAS interface is doing. And I run into this quite a lot where folks don't realize that they have to go and actually figure out who's going to be in charge. To expand beyond that, not only do you have to go and be cognizant of priority arrays with BACnet, you also have to be cognizant of the kind of data types and what's the word I'm looking for? I don't want to say data models, but basically it is a data model. So for example, a light may be based on a light type. And so the lighting system may say all fixtures of this type are in this group, and they may call it a lighting group. Whereas you only care about lights for a specific space, but a group does not match up to a space. So a group may be an entire floor, and you are looking for just a single space. And that's where the challenge begins, because you've got these points that you're trying to match up, and now you have to have a way of going and matching them up. So this is where you often have to work with the lighting manufacturer before stuff even gets installed, because they'll go program their lighting database and you have to explain to them, hey, look, I want to control these spaces. You just have a giant lighting group. I need you to actually create your lighting database to be by space and to take all the different groups that are in that space and group them up into a space kind of asset, a space class essentially, and then that will be able to be discovered. Is what they'll do is they'll take their database of BACnet points, and they'll create a device for each space. And then that device, you will go and actually pull that in. And that's often what will have to happen. But if you're not getting ahead of that, then you're going to have a lot of hurt because you're not going to be able to have that granular level of control. And then folks are going to be pointing fingers and wondering why everything's broke. And then lighting manufacturers going to want to charge $10,000 to come back out, redo all that. And it's just all kinds of not fun. From here, then, you go into the programming involved, right? So do you have to go and map to certain points? Do you have to go and say, well, if the space is not occupied, then I'm not going to have my lights enabled. Well, then that looks completely different programming-wise. You may have to go and tie that in to the actual field controller, or you may have to tie that into the supervisory device, just depending on how you've got things set up. So you've got to go through programming now. And then finally, you have to do your interfacing. And as I mentioned, this can be pretty nasty because, for example, with Niagara AX system or some of the older kind of generation systems, they would typically not support hundreds of users. That was not their intent, especially if the system was dependent on Java and was not HTML5. Then you had that additional fact of how do I get a Java application onto someone's mobile device? You simply can't. Well, you can, but it's all kinds of nasty. I don't recommend it. So now you have to think through that aspect. And often what happens is folks they'll think through all the 5 questions I asked. They'll start doing the identification of these different variables, and they'll go and set them up. But then they get to this interfacing of the integration, and they're like, uh-oh, I should have thought about this a lot sooner, a lot earlier. And this is where things kind of fall apart. So if you're going to have anything, my general rule of thumb is that if you're going to have any integration that involves a tenant, that involves a user interface that is mobile, that is being used by more than just a handful of people, you're going to want to go and map that out and figure out all that technology before you ever start working on the job. Because if you don't figure that out, that's just going to be pretty ugly. It's not going to work well for you. So that is kind of protocol integrations. You see how we're working through this, right? You see how we're asking our questions, our 5 questions. Why are you doing the integration? What outcome are you looking for? What are the user preferences? Who's going to support it? What systems do you have? And we're thinking about those 5 questions as we then move through the implementing of the physical, the data, the programming, as well as the interfacing. So we're kind of putting all of this together. Now we move on to integration number 3, which is the weather station to building automation system. Now this is a programmatic integration, meaning that we actually have to write code to make this work. So first we have to understand, why are we doing this integration? Well, we want to pull data from the weather station so that maybe we can get more advanced data. We can have forecast, maybe we can have wind speed, maybe we can have light level, all sorts of things. That way we can maybe take a more proactive control of how we do our equipment. Maybe we're going to see that our calendar, our high temperature is going to be 30 degrees, and because of that, we're going to be going and starting our heating plant a little bit earlier than normal. So just different variables that we could pump into our system. Now, I will be honest with you. As far as this kind of proactive control, it is definitely not the norm. It's definitely not what you're seeing. There are systems out there that do this by default. They're more on the smart equipment side. So you're talking, the Johns Controls, the Daikin's of the world that are really highlighting their smart equipment. I think Trane has some smart equipment as well. I'm not familiar with their rooftop solutions as far as smart equipment goes. But as far as being able to proactively take data from a weather station and then control your air side or your water side systems differently, is not as widespread as I believe it'll be in the next couple years. However, that being said, it is still something I see a lot of people do where they pull weather stations in because they want to go and kind of have an idea of what the outdoor air temp or what the dew point is or things like that. So why are you doing this? Well, because I want to have outdoor air data. What outcome are you looking for? Maybe you're looking for better control of your economizer. Maybe you're looking for better sequencing of your plant. What are the user preferences? Well, we just want to pull in the data. We don't really have a visualization preference as long as the data is accurately pulled in. Now, the big one, whenever you're doing a programmatic integration, is going to be who is going to support this integration. Because think about it, right? You're writing code. You're consuming an API. And if you've never looked at an API, I really encourage you to try to look at some APIs. You deal with them every day, even if you don't realize that you're dealing with them. If you've ever made a bank transaction, you're working with an API. If you've ever done a purchase on Amazon, you're working with an API. And APIs are things that we touch every single day. However, whenever you're dealing with an API basically allows you to interface with the programming inside of an application. So inside of an application, you may have a point called get weather data, and it returns a bunch of different values. Well, what happens if the person who runs that API decides to change get weather data to then be like get temperature data? Well, now your program that is calling against that old deprecated function, that's what they're called when they're no longer supported functions. They're called deprecated functions. So you're calling against this deprecated function and your integration is broken. That's why programmatic integrations are some of the most difficult to support. Usually you'll have the programming capabilities if you're doing this. Only a handful of times have I seen folks try to take this on without having the skill set to go about implementing these kind of integrations. With that being said, very rarely is the support structure put in play. And then finally, what systems do you have? This is always an interesting one because one, you want to make sure your BAS has a way to consume APIs or to at least let you write programs to consume APIs. But then you want to make sure that the API actually has the data points you need. So those are kind of what systems. Now, as far as the physical connections go, the big thing is to make sure that the BAS has access to the outside world, especially if that's where the API is coming from. So you don't always need access to the outside world. And if you're using an API from maybe a lighting system or using an API from a security system, then those APIs, they might actually be inside the network, meaning that you don't need to get outside of your network to access them. However, if you're dealing with a weather API or maybe a calendar or something like that, that you're trying to pull in outside data, first thing you need to make sure from a physical connection perspective is that you can actually access the API. And that access doesn't get shut down for whatever reason. Someone changes a firewall rule, someone changes a route, whatever. You want to make sure that that API stays functional. Then the data connection. This is kind of where you're going to live when you're doing programmatic. You have this thing called a data adapter pattern. So if I were speaking Chinese and you spoke English, we would need something to translate from Chinese to English. Well, that's what a data adapter pattern does. Basically, when you go and you do a request to an API to give you data, that API's request has a specific data model. And your program needs to understand that data model to understand what format the data is going to come in from that API. And then you've got to write a integration called a data adapter pattern where you go and you take that data and you format it in such a way that your BAS can consume that data. That is the data portion of this. And this gets into a whole slew of things like how often do you poll? Do you use a subscription versus a polling model? Do you go and have to go and potentially lose granularity of data. For example, if it's providing 7 decimals worth of details on your temperature and you can only support 2 decimal points, is that okay? I mean, 9 times out of 10 it is, but you've got to understand these data normalization concepts. Once you've done that, and I know I kind of like just glazed over that, like, oh yeah, you just kind of do these things and then you're done. It's much deeper than that. But once you've done that, once you've gone and figured out that data part, and for those of you who are like, but Phil, how do I learn this? Oh, well, there's a slew of things. I would go and look up some RESTful API tutorials. That would be RESTful, RESTful. And I would look up tutorials for that where you can actually practice maybe using like Visual Studio and CSharp or, NetBeans and Java. Use those and then actually consume some APIs. You can get some free APIs from Weather Underground. I like to play with their API. It's pretty well documented. And I like CSharp because you can use CSharp there's this website, I forgot what it is. It's like CSharp to JSON or JSON to CSharp or something. And it basically takes the data model for an API and converts it to a CSharp class. That way you can consume the data. And if some of you this totally like just flew over your head, don't worry. This is a very advanced conversation point right here that most of you are not going to be touching, at least for the foreseeable future, unless you're doing, multi-system integration. You're not going to be really touching this. So that's what you do. You figure out the data, and then you do the programming. Now here's where you take those data points, you do whatever programming you got to do. You global share the outdoor air temperature, you do your calculations for enthalpy control, whatever it is you have to do, this is where you do it. And then finally, you go and you identify the way of interfacing with the integration. Now in this case, once again, you're probably just going to be wanting to visualize the outdoor air temperature. So putting it on a graphic or just having it in your system tree is going to be good enough. But, if this was something that the customer actually wanted to interface with, then you got to get into, well, do I have to mess with polling? How do I make sure I have the most recent data? All those kind of things. So there you have it, folks. 3 real-world integrations that are commonly done on the job site. Although I will admit the weather station to BAS is not as common as the other 2. But they're fairly common. You may run into them on more advanced projects. But this is how you go about understanding the outcomes that need to be achieved from the integration and how the integration is going to be used. And then how you go about implementing the actual integrations. So kind of took a look at the why and then we took a look at the how. Now, if some of these topics, subnets, networks, APIs, data models, all this jazz is just not familiar to you, but you feel like you hear these terms a lot and you feel like, man, if I just knew this stuff, I could take my career to the next level. Or maybe you're a little scared because you realize that this stuff is coming and you don't want to become obsolete because you don't understand this stuff. Well, then I'm going to provide a link to my IT training course, which I really, really, really encourage you to go through. It's my most popular online course to date. And it will teach you all of these things. It'll take you through how all these things work, and you will come out of it understanding and being conversational about all of these concepts. Because at the end of the day, that is the biggest thing most BAS professionals need, is to become conversational in IT. So I really encourage you, be probably one of the best investments you'd make this year for you to go and pick up that IT course. With that being said, this ends our 3-part series on systems integration. And in our next episode, we are going to start looking at systems thinking. So we're going to look at a concept that I've explored very deeply in my control sequence fundamentals course. And we're going to be looking at systems thinking. How do you think from a systems perspective? How do you troubleshoot from a systems perspective? How do you kind of digest a sequence of operations? We're going to start going through that in the next couple episodes. So that being said, thank you so much for being here. I really appreciate it. And I look forward to talking to you all again next week. Be sure to go to buildingautomationmonthly.com/108. Once again, that is buildingautomationmonthly.com/108. That will have all of the content and links available that I've discussed in this episode. So until next time, keep learning, keep challenging yourself, keep growing in your building automation knowledge. I'm so thankful to have you listening to me, and I will talk to you all again next week. Take care.